Hi and welcome to another video. Today I'd like to talk to you about Destination Network Address Translation, or Destination NAT, more commonly known as port forwarding. In order to understand how NAT works, it's important to understand how TCP ports work. Port numbers are an integral part of how TCP networking works, and they allow different network applications or services to coexist on a single host machine. To understand how TCP ports work, let's take a look at how package delivery works at a major company. This building is owned by Future Enterprises. It has hundreds of offices and thousands of employees. Each office has an employee in it, and each office has a room number. Let's take a look at the sequence of events for delivering a package to an employee at Future Enterprises. The package is delivered to the building by a postal worker or courier company. They know where to take it based on the address that's printed on the shipping label. When the package arrives at our company, a decision needs to be made as to where to take the package. The address on the shipping label is not sufficient. Additional information is needed in the form of a room number and optionally a person's name. In the mailroom of Future Enterprises is the postmaster for the company. His job is to receive packages on behalf of employees and then deliver it to their offices. The postmaster receives the package and checks who it's for. Keep in mind that there are thousands of people working in this building, so the postmaster does not know the name and office number for every person. He relies on the room number printed on the shipping label and then hands the package to one of his runners to deliver it to the right room. So let's take a step forward and see how this applies to computer networks. As in the previous example we had in a building, this building represented our server. This can be a full-blown enterprise-class server run by a massive corporation, or it can be something as simple as a Raspberry Pi hosting a local Minecraft server. For the sake of this example, all communication will be limited to the local area network. A server may be used to run one or more of the following services: a MySQL database server, an Active Directory domain controller, or a simple HTTP web server. Note the number next to each service. This number is the port number associated with that service. There are some standard ones, but there are many services that use manually configured port numbers. We will be looking at a request packet sent to the HTTP or web service running on the standard port 80. As before, let us look at the sequence of events for a packet sent to the HTTP service. The package is delivered by the local network based on its destination IP. In the example, that is a static IP address assigned to the server's network interface card. When it arrives, the networking software on the server needs to make a choice regarding what to do with that packet of information. Part of the operating system's TCP/IP stack is a piece of code that acts as the postmaster for the system. In order to know what service the packet is supposed to go to, the postmaster inspects the TCP header of the packet to determine the port number. The postmaster strips away any lower-level data that's not needed by the application and passes the packet along to the appropriate application running on the server, in this case the HTTP or web service. Now we can get to the grits of the matter. Actual port forwarding, or more accurately, destination network address translation. Let's take a look at our network setup. We have a router with two network interfaces, an external or WAN interface and an internal or LAN interface. The router has some firewall configuration on it, and on the internal network we have a server running a website on port 80. The server has an IP address of 192.168.1.20. A user outside the local network is trying to access the web server on our internal network, but the only information he has is our external IP address and the fact that the service is running on port 80. As before, we will follow the sequence of events for an HTTP request packet from a user on the internet. The packet is routed to our router through the internet based on its destination IP address. When it arrives on the WAN port of our router, the router opens up the TCP header to see if it was supposed to do anything with this packet. It cares mainly about two things: that the packet was meant to reach itself and not someone else, and what the destination port number on the TCP header is. The router then does a lookup on its firewall table to see if there are any rules that would apply to this packet. Here you can see a typical, if somewhat simplified, rule for forwarding a packet to the internal network. You can see the rule specifies that if the router receives a packet on its WAN port, let me just get some highlighter, if it receives a packet with this IP address, its public IP address, and on port 80, then it's supposed to do a destination network address translation on it. So the command that we're giving it is to change the address to 192.168.1.20. Sorry, this is a mistake. There should be a 20 here. So it's supposed to go to address 192.168.1.20, and the port is supposed to remain unchanged. So the firewall application on the router will then proceed to do that change to the packet. It will repackage it, and then it will pass it along to the web server. The web server will then be able to do whatever it needs to do with that packet, and if needed, it will then issue a response to the originating IP. That is, in a nutshell, the basics of TCP ports and port forwarding. I hope you've enjoyed the video, and I hope to see you again soon.